All right, well, all we're going to go ahead and do right now is take a look at our focus activity. Emma, if you would turn off that light for me, please, or thank you, Reese. Okay, so this goes back a ways. We're looking at a 2x2 contingency table, and we're going to use the chi-squared test for independence. It says the hair and eye colors of 150 randomly selected individuals are shown in the table below. Okay, so we have blue, brown, green for the eyes, blonde, black, brunette, and red for the hair color. At a 5% significance level, the critical value for chi-squared is 12.59. Test at a 5% level whether there is an association between hair color and eye color. Okay, so one other thing they might commonly go ahead and have you do that I'm not having you do here, but I do want to bring up. Remember, there were two sentences that typically you're going to write at the beginning of a chi-squared problem. Do you remember what they're called? The first one starts with an N. The null hypothesis, and then the alternative hypothesis. Okay, so what does the null hypothesis say? Okay, what's that, Reese? Well, we're not ready to reject or accept yet because we don't know what our findings are. So does the null always say that the two quantities are independent or not independent? Null says that they are independent. Okay, so like here, we could go ahead and say eye color and hair color are independent of one another. So what would the alternative hypothesis say? Yeah, eye color and hair color are not independent of each other. And remember, when we are done, once we have our findings, we either say we accept the null hypothesis or we reject the null hypothesis, because you could test at a different significance level and get a different result. Okay, so we got my data here for the 150 people. I've gone to my calculator. I know that we want to go to calculate. Where do I go from here? How do I input the data? Well, not yet. We have to use something. It's a rectangular way of organizing. Matrix, there we go. So the matrix templates are right here between 9 and the catalog button below delete. Okay, and we want this one in the second column, the 3x3. Because what are the dimensions of my table? Ooh. It's a 3x4. So in the table, they're just not providing the row total and the column total. Okay, so the 3 is good, but I want to go ahead and change that to 4. So 3x4. Now I'm going to go ahead and input all my values, 14, 10, 21, 5. Back over here, 11, 32, 20, and 12. And then we have 5, 2, 14, and 4. Okay, so I've got it in, but then I needed to do something with it. Okay, so we need to call it a name, so we're going to call it X. So remember, we store it. We hit the control button, and then the variable button right above 9. That gives you the little arrow, and whatever you type in, that's what the calculator is going to know X as, or whatever you decide to put in. Okay, so now we go to menu, but where do I go? Statistics, stat test. This is the chi-squared test for independence. And we want the two-way test. Remember, this is a two-way contingency table. Okay, so I'm going to choose that. We're going to type in the matrix that we just stored. And here we go. It says that my chi-squared is 18.4147, so we'll say 18.4. Yes, ma'am. Well, that means that you have quantities that are interacting with each other individually. Like you can have any combination of eye color and hair color. Because remember, you're looking at the different cells of data. Now, it's a two-way table because you can also take the column totals, but you can also take the row totals. Okay, so like here, if I took all the column totals, you got 30, I believe that was 44, 55, 21, and then you can take the row totals, 50, 75, that's 25. Okay, 30 plus 44 plus 55 plus 21, that is 150, as is 50 plus 75 plus 25. Because remember, one of the other things you could potentially be asked is what's the expected value for a certain combination, and that I actually did on here. Okay, let me go ahead and go back very quickly and write it out. What was it, 18.4? Okay, so 18.4. Now, what we wanted to do was compare our chi-squared calculated value to the critical value. So we see that 18.4 is greater than the 12.59 critical that we have. So what is this telling me? Do we accept that null hypothesis that these quantities are independent, or do we reject the null hypothesis? They are not independent, they are dependent. What happens if it's bigger? We reject. If your chi-squared calculated value is larger than the critical, we reject the null hypothesis. They are dependent. Now here's the thing about chi-squared. Remember, it doesn't tell you what the relationship is. This is just our indication that yes, there's got to be some kind of relationship going on. And then it would be, our job to kind of figure out what we believe that relationship to be. Okay. Now it says right below that, what's the expected value for green eyes and red hair? Okay, so I'm going to go ahead and find this particular cell. Here's the green eyes. Here's the red hair. Okay, so this looks like it's row 3, column 4. Now, we're going to go ahead and do this both ways. How would I do this by hand if I wanted to see the expected value for that cell? Now, you are going to be dividing by 150, but what would I do in the numerator? There you go. I multiply the column total by the row total for that particular cell. So I'm going to take 21 times 25, and then I'm going to divide that by 150. So if I come on over here, 21 times 25 divided by 150, okay, 7 halves, which is 3.5. Okay. Now, let's go ahead and check this. Does anybody remember how I bring up the expected frequency table in the calculator? Okay. So I'm going to hit variable this time. No need for control. Okay. And then I want the EXP matrix. Okay. So then it brings that up. Click enter. And now just look for that position. Row 3, column 4, we exactly got 3.5. Does anybody remember what the expected frequency values mean? There you go. This is what we would expect to get if hair color and what we're talking about, eye color, were independent of each other. Okay. How many people remembered all the steps for these? Okay. And that's what we're going to be doing as we go through them, and we're going to continue to spiral these ideas back in. Okay. So we did agree. We're going to go ahead and turn the homework in on Monday. Give you a little extra time. That is the only other thing I had planned for today. Did anybody have any questions about anything that's going on?
Could we ask you questions?
Sure. That was a notification on my phone.
Okay.
That's terrible. That's a Star Trek noise.
So concerning.
What?
I have like a Star Trek intercom up outside of my room.
Yeah, cool. It used to be the red alert, but that would last too long and it was loud, so I just did it to the all attention. All hands on deck.
Can we turn this into the box?
Yes. If you were one of those people who also, I gave you the operations work from yesterday, if you go ahead and get that completed, and then we can go ahead and turn that into the box. I'll get all that graded. Okay, so since we're going to go ahead and turn this in on Monday, I'll go ahead and answer a few questions on the assignment. Maybe if some people are having some trouble, I can kind of help you along. Let me see what I do with my... Here. Don't need that anymore. Aha! Excuse me. Okay. Let's see here. Number 6.
We have the pepperoni.
Oh, okay. Pepperoni, all right. Oh, 7 people left. Okay. All right, you ladies have a good weekend.
Thank you, Mr. West.
Okay. Bye. Thank you, folks. Oh, it's a read on the camera. Oh, I must have forgot I had it up. There we go. Let's see here. Okay. Okay. All right, you have a great day, man. Bring home those Spurs. Why does everybody laugh when I say that?
It's 5 years.
Because we can do it. This is the year. You just have to believe.
10 years.
You know, actually, as funny as it is, like Blowing Hive, some years, not all years, some years we perform extraordinarily better during the summer games. Like I saw one year my sister's high school year, and we got 4 touchdowns.
Hey, well, I think this is time for Monterey's streak to end. Anyways, okay, so what questions on the assignment would you like to look at?
Number 5.
Number 5? Okay. Let's see here. Number 5. Okay, and I apologize for the condition of this. I just took a snapshot very quickly with the smaller copy. But number 5 says, if we use a value of 3.14 to approximate pi, and we want to calculate the volume of a sphere of radius 34 plus or minus 1 centimeter, what's the range of values we might expect to get, and what's the percentage error? Okay, so what I did, remember when we add plus or minus 1, that's the absolute error. So what I'm going to go ahead and do is apply that to the length of the radius 34 centimeters, because the first thing I want to do is get the range of values. But do we remember how to find the volume of a sphere? Okay. What's that, Jen? Oh, now that's for a 2-dimensional circle. Okay, you're right. Okay, so the volume of a sphere it is. Really, that's it? Okay. 4/3 pi r cubed.
I thought that was for, like, or is that one?
They're very similar, but this is for a sphere, yes. Okay, so 4/3 pi r cubed. All right. Now, I'm wanting to go ahead and find the range of values for the volume based on this error that I've been given. So we've got 2 of these guys here. Because it's plus or minus 1 centimeter, we're going to be looking at a radius of 33 centimeters. And then we're going to be looking at a radius of 35 centimeters. Okay, because it's plus or minus 1 centimeter, right? Yes.
Sorry. Operation there. You want it to 3/6?
3/6, yes, ma'am. Yes, please. Okay, and I believe what I did on this one was I went ahead and applied the 3.14 because that's what the problem had stated. So let's go ahead and calculate these values. So if we go ahead and use 33 with 3.14, let me get rid of all this. Okay, so it's parentheses, control divide, 4/3, parentheses. Okay, if it'll get out of there, parentheses. And then it's pi times the radius cubed. Oh, and in this case, I'm not using pi itself. Yeah, I'm using the 3.14. Whoa, did you see that? It erased the whole thing. It wants me to do all over again. Dang it. Okay, and then we have the 3.14 times, the first one we're going to do is the 33 cubed. So 4/3 pi times the radius cubed. Okay, so I'm going to end up with 150,456 cubic centimeters, and I believe there's a little more to that, but 0.24, so not a lot more. Okay, and then I got to type in this formula again, but I'm going to change the 33 radius to 35. Okay, where I get 179,503, and again, I believe there is a little more after that. Okay, so 0.3 repeating. So what I'm going to go ahead and do is now say, okay, so the volume is between 179,503, 179,503.3 repeating cubic centimeters, and what was the previous one? Oh, it was 150,456.24. 150,426 point, was it 24? 24. There we go. So there's the range of the volumes based on the error. That's it. Now, it's not the entire problem, because now it also says, and what might we expect to get, what's the percentage error? Okay, so we're looking at this with 3.14. So we're going to go ahead and use the radius of 34, but we're going to use 3.14, and then we're going to use the approximation for pi. Okay, so remember how we go ahead and find percentage error. We go ahead and start with absolute error, which is to take the approximate value minus the exact. Now this is in absolute value. Now in order to find relative error, what do? We divide this by what? Okay, the exact value.
Yeah.
This provides me the relative error, and then in order to get the percentage, I got to multiply by 100. Okay. So what we're going to go ahead and do is take that value of 34, the radius, but I'm first going to go ahead and approximate it with 3.14, and then I'm going to use the exact value with pi. So let me kind of illustrate what I'm referring to. So I'm going to take the absolute value of 4/3 times 3.14 times 34 cubed minus 4/3 times pi times 34 cubed. See, I'm doing one with pi, 3.14, but then the other one I'm using the exact approximation of pi, the exact value. And then I'm going to go ahead and divide by 4/3 pi 34 cubed, and then of course I'm going to multiply that by 100. So is everybody okay with what I'm doing? Okay. Yes, ma'am.
What was the point of the first part there?
It was just wanting the range of volumes based on the error.
Oh,
Okay. Now I'm not going to type all this in at once. I'm going to go ahead and type in the two expressions separately, and then I'm going to go from there. Okay. Or, well, maybe I'll go ahead and throw in the absolute value. Why not? We'll see. Okay, so let's see here. Where do I find absolute value anyway? It's next to the 9, okay, between the 9 and the catalog, right here where we just found our matrix. It's in the second row, first column right there. Okay, so first thing I need is control divide. Let me go ahead and put parentheses on this guy. Okay, so I want 4/3. Okay, then this first one, we're going to go ahead and take 3.14 times 34 cubed. Okay, now we're going to subtract. Okay, do the same thing. Parentheses, control divide, so I'm getting 4/3. Okay, 4/3, but now we're going to use the approximation for pi times 34 cubed. Would everybody agree? Okay, so here's the approximate minus the exact. So I'm getting this right here, 83.4635. So I want to go ahead and divide this by, so let me just go ahead and type it in one more time. Control divide, so we got 4 divided by 3. Okay, then we're going to use the approximation for pi, 34 cubed. Okay, so I'm going to go ahead and take this guy right here, and I'm going to go ahead and divide him by this one right here. Okay, and then I want to go ahead and multiply him by 100. So let's say I want to round this to 3 significant figures. What would that percentage be? 0.0 what? 0.0507. Okay, so the percentage error should be about 0.0507%. So actually, according to this, using 3.14 versus the approximate value, was there really that huge of a difference? No, not huge. Okay. Ella, is this how you solved it?
I stared at the problem for a long time.
Okay. She stared at it for a long time. Okay. All right. Well, does that make sense, though? Does anybody else have any questions? Oh, my God, it's 2:08. Wow. You know what? Time flies when you're having fun. Okay. So this will be due on Monday.